Hey guys, it's Mr. Riz again, and we're going to go to the second part of section 1.3, and we're going to find strategies of finding limits that do not exist. So what we're going to do, we've studied several different functions whose limits can be evaluated through direct substitution. Remember, that's just plugging it in. This knowledge, together with the next theorem, can be used to develop a strategy for finding limits. What we're going to do is basically find a function that agrees with all points except one. So say I have a function that looks like this, where I have a discontinuous point there. I'm going to find the function that fits exactly right on top of it and covers that point. Because if I can find the point, or find the function that covers that point, I can find the limit as we go to that point, and assume that it's right on top of our discontinuous point. So this is what this fancy explanation is saying. So if we find that f of x equals to g of x for all x except for our c, which is our open point, we can find out that the limit of f, as f of x approaches x, or as approaches c, is going to be equal to directly substituting in c for g of x. Alright, so what we got is this function here, and first what we'll do, I'll just explain it out, and then we'll do another one where we write it out. So if we're trying to find the limit as x approaches 1 of x cubed minus 1 over x minus 1, if we were to directly substitute that in, we get 1 minus 1 over 1 minus 1, which is a big 0 over 0, which is not equal 0. It does not exist. Alright, so what we're going to do is find out a function that is equivalent to that except for at the point. And what we're going to do is basically factor out the numerator. We can factor out the numerator to x minus 1 over x squared plus x plus 1 over x minus 1. Because that's our denominator. Now we can cancel out the x minus 1s from both types. So our equivalent function, our g of x, is x squared plus x plus 1. And it works for every single number just like this function except for x equals 1. So now that we have our equivalent function, all we need to do is directly substitute in 1 into this equation. So just to show this visually, here is our original function, our f of x. It works for every single point except for there's that open hole right at 1. Here's our g of x, our equivalent function that we found, that has that point filled in. So it's the exact same thing except for at that point. So we can figure out where the limit exists by now directly substituting 1 into our g of x. So we do 1 squared plus 1 plus 1. 1 plus 1 plus 1 is 3. Yippee! So the big thing we're going to be looking for is understanding what problems we can use direct substitution for. Basically any problem that we don't get 0 over 0. Next, what we're going to try to do is find a equivalent g of x for f of x and plug in our c into that g of x. One thing we should do is double check with our graphing calculator, like how we did in section 1.2, to evaluate the limit. Now let's start doing some problems here so I can work it out in case that explanation didn't work for you. Alright, so let me get a problem. Okay, so I have the limit as x approaches 2, x squared plus 6x minus 16 over 3x minus 6. Now if we try to do direct substitution, let's see, we get 2 squared is 4 plus 12 minus 16, oh look at this, over 6 minus 6, we get 0 over 0, that dreaded 0 over 0. So it doesn't work with direct substitution. What we're going to try to do is find an equivalent function. Well, let's break it up to the top and the bottom. We could factor out the numerator. And if we factor out the numerator, we get, that is, let's see, 16, that'd be 8 and 2. So x plus 8, x minus 2. Well, we don't have an x minus 2 on the bottom of the denominator, but what we could do is if we factor out a 3, we get an x minus 2 as well. Alright, so now if you look, our equivalent, we have x minus 2 on the top and the bottom. We can cancel that out, and so our equivalent g of x is x plus 8 over 3. Now what we can do is now take the limit as x approaches 2 of g of x. And that's basically going to directly substitute 2 in for there. And we're going to get 2 plus 8 over 3, which is 10/3, or 3 1/3. Now we can use the graphing calculator to double check. Alright, this should be pretty good. What we're going to do in the next section is focus on ones that are a little bit more complicated than this, ones involving square roots. Alright, if you need any help, ask. Good luck.